Renewable energy sources, solar, wind, and hydroelectric power. Decarbonization of the energy sector to mitigate the consequences of climate change is possible by incorporating a greater share of electricity from renewable sources, and thus reducing the share of fossil fuels in the energy mix, improving energy efficiency in general, and increasing energy storage capacities. Renewable energies are increasingly permeating energy systems, causing significant shifts in the energy production mix. The success of transforming the electricity mix is dependent on the variability of renewable energy sources, such as solar photovoltaic, wind, biomass, and hydro. The share of renewable sources in Romania's energy mix was determined based on real data on electricity generation and consumption in 2019. However, the current electricity consumption has significantly surpassed the electricity produced from renewable sources. Specifically, the combined contribution of hydro, solar photovoltaic, wind, and biomass energy accounted for 39.86% of the total electricity consumption. Introduction. Sustainable energy encompasses not only the generation of energy from renewable sources, but also its distribution and optimization. The definition of sustainable energy differs from that of renewable energy. Indeed, renewable energy is only one component of the concept of sustainable energy. Sustainable energy, on the other hand, denotes a model of sustainable development in which society can produce and use energy without harming the environment, avoiding excessive resource consumption in comparison to what the planet can produce. The circular economy chain in the energy field is used in the sustainable energy model: reduce, reuse, recycle, and recover. As a result, sustainable energy encompasses all stages of the energy process, from production to distribution, consumption, and disposal of systems and devices, as well as greenhouse gas emissions generated at each stage. Furthermore, societal needs must be considered to ensure adequate energy support for social and economic development. The ecological transition must gradually replace fossil fuels, which are the primary cause of climate change, with renewable energy sources such as solar, wind, hydropower, biomass, and geothermal. Renewables, however, would not be sufficient to support Western countries' energy-intensive lifestyles. At the same time, it is necessary to review how energy is used, with a focus on the energy efficiency of housing, transportation, and all other activities. Environmental sustainability refers to the conservation and maintenance of natural resources to ensure the survival of life on Earth. Social sustainability, on the other hand, entails the ability to ensure people's well-being and high quality of life. And economic sustainability is the ability to generate income and jobs for all. The steps required to achieve the sustainable energy goal by 2030 include strengthening international cooperation, facilitating access to technologies and investments in clean energy infrastructure, and improving energy efficiency, beginning with how electricity is distributed. Electricity generation through wind energy plays a crucial role in decarbonizing the energy system and fostering the sustainable development of our society. Wind power, as a renewable and clean energy source, has significant environmental, economic, and social benefits and helps to reduce dependency on non-renewable fuels such as coal and oil. Using wind energy to produce electricity helps to significantly reduce greenhouse gas emissions. Compared to conventional energy sources such as coal and oil, wind energy does not produce significant emissions of carbon dioxide, CO2, and other polluting gases, thus helping to combat climate change and improve air quality. Methodology. Governments are attempting to diversify the energy mix by including renewable sources to mitigate the negative environmental effects of using fossil fuels and to reduce carbon dioxide emissions. This study investigates the variability of energy production using renewable sources such as wind, solar, biomass, and hydro, as well as the extent to which they meet the electricity demand. In the context of environmental degradation and the need to stop irreversible climate change, the use of wind energy, solar energy, biomass energy, and hydro energy has grown in importance. However, due to the volatility, randomness, and intermittent of these sources, the design of an energy system that will eliminate energy production from fossil sources is difficult to achieve. Romania has distinct geographical characteristics that support the development of various forms of renewable energy. The potential of these renewable energy sources, solar, wind, biomass, and hydro, to produce energy, and, consequently, the degree of coverage of domestic consumption, is examined in this study. The flowchart in Figure 1 outlines the basic process used to analyze renewable energy production. The first step is to collect data on renewable energy production, which may include data on the production of different types of renewable energy sources, such as solar, wind, and hydro, over time. The next step is to clean and process the data to ensure it is accurate and usable for analysis. Once the data is prepared, the analyst can explore it to identify trends and patterns. Statistical analysis can be used to quantify relationships between different variables, such as the relationship between solar energy production and weather conditions. Visualizations will also be created to illustrate patterns and trends in the data. Based on the analysis, conclusions will be drawn and recommendations will be made. Hydroenergy generates a significant amount of energy, accounting for approximately 26% of Romania's energy consumption in 2019 and producing more energy than wind and solar combined. The highest hydro production in 2019 occurred in the months of spring and summer, particularly in May, June, and July, when this source contributed the most to total energy consumption. According to Figure 2, the highest share was 71% on May 26 and the lowest share was 3.6% on November 3. As shown in Figure 3, the maximum energy production from the hydro source coincided with a lower energy consumption. The lowest energy consumption was recorded on April 29. According to Figure 4, wind turbines generate an average annual energy production that covers consumption in a proportion of 8% to 14%. According to Figure 4, wind turbines generate an average annual energy production that covers consumption in the range of 8% to 14%. Wind turbine annual energy production, like photovoltaic energy, is highly variable, being lower in the summer and increasing in the winter and spring months, as shown in Figure 5. Wind energy production in 2019 accounted for 11.3% of total demand in Romania. The largest share of the energy produced by wind turbines in total energy consumption was 47.3%, recorded on December 23. Wind energy has a lower production in the summer, with less than 1,000 MW produced, and a higher production in the winter and spring, with production ranging between 1,000 and 2,800 MW. Among these resources, hydroenergy was found to be the most important, producing far more energy than the combined outputs of wind, biomass, and solar PV sources. In 2019, hydro energy accounted for 71% of total energy consumption. Wind and solar energy have very high variability, indicating that the two sources cannot be complementary. The analysis revealed that renewable energy sources, such as wind energy, solar energy, biomass energy, and hydro energy, when integrated into the current energy system, can meet current annual electricity demand by a maximum of 40%, consequently reducing greenhouse gas emissions compared to systems based entirely on fossil fuels. What do you think of our video? Let me know in the comments section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.